Okay. Hello, everybody. I hope you can hear me. Welcome to RIPE NCC webinar. My name is Çiğdem Şenol. I work for RIPE NCC Learning and Development Team almost for 3 years. Based in Amsterdam office, I'm technical trainer and also development officer. So I'm responsible to give face-to-face trainings and also webinars. And as development officer, I'm responsible to create course content for the topic. I'm the subject matter expert. So I'm responsible actually to create content for BGP and routing security courses. And today we have a webinar for 2 hours, but let me first share my presentation. But before starting, I would like to repeat it again, what Alex said. There is a simultaneous interpretation, so it is the English channel. Now I'm talking in English, but actually Maxim will be translating it so that you can understand better. And for your question, you can ask them any language you want by typing it in the chat window, and we will try our best. Let me share my screen. And by the way, Alex, as the host, I'm allowing actually the participants to enter, and I see still there's some participants attending the session. Now we have 87 people. And maybe it will be better if you check it and admit them while I was presenting. Maybe I can miss it. Okay, let me share my screen. Before I admit this one as well. Okay, I hope you can see my screen, and let's switch to the presentation window. Okay, now all is fine. So let's start with the presentation. Again, welcome and good afternoon. Welcome to the RIPE NCC RPKI operations webinar for Ukraine. And before starting the session, I would like to actually inform you that this session is being recorded. So, for example, if you miss one of the part, or if you would like to remember the details later on, then this recording is here for you, and we will share it with you after the session. So you can watch it, you can remember the details, and of course, if you want, you can share it with your colleagues as well. So what will we talk about today? We have 2-hour webinar. The main topic is RPKI, but before then, we will be talking a little bit about BGP security, because we need to understand first why we need it. What's the problem with BGP, and what is the routing security vulnerabilities of BGP, and how RPKI helps it. So we have 2 hour webinars. I will present the first part of the session. After the first part, we have a short break for 5 minutes, and then we will switch our roles with Alex, and Alex will be presenting the second part. And if you have any questions at any time during the session, please write it down in the chat window. Please feel free, just write it in the chat window, and who is not talking at the moment, Alex or me, will be answering your questions at that time, actually. So let's look at the content, what we will be talking about. This is the agenda, what we will cover today. First, we will talk about BGP and routing security, because as I mentioned before discussing RPKI and what it does, how it helps, first we need to understand the reason behind it, why we need to implement RPKI in our network. And then, of course, we will discuss in detail what is RPKI, what is a ROA, and how we can create it, how RPKI helps with routing security, and how we can use RPKI data to validate BGP announcement, and how we can make routing infrastructure better and more secure. And at the end of the session, we have a short part actually where Alex will be showing you some statistics, RPKI statistics for Ukraine. So it will give you some idea actually how Ukraine is doing with RPKI. For example, for how many prefixes rows are created and origin validation is successful, and how actually Ukraine helps the global internet to become more secure and stable. And of course, during this, we have some demonstrations. So we will show you all the steps you need to know to implement RPKI in your network, how you can create ROS, how you can run validators, which is another important step actually in this RPKI, and how you can use RPKI data to validate your BGP announcement, and of course, how you can use this RPKI validation result to make better routing decisions. And yeah, there are some people, let me allow them at the same time as well. Okay. Let's start with the first section, BGP and Routing Security. So let's try to find the answer for this question. Is BGP secure? So, as all you know, BGP, Border Gateway Protocol, is the protocol which all we are using on the internet to communicate with the other networks, with the other autonomous system. And by using BGP, networks actually exchange routing and reachability information with the other. And it is the only protocol. There is no alternative. That's why it's always called as protocol of the internet. And by using BGP, you announce the IP address block you have, and you tell the others how to reach that block. Let me explain how BGP works. Let me remind it, actually. You already know it, I'm sure. Just let me remind it how it works so that we can understand what the problem with BGP. So let's think that we have two networks, network A and network B. And both of them has their own IP address block. For example, network A sends an BGP update message and announces the network it has. It says that, hey, network B, I have this network 10.10.10.0/23. And if you would like to reach that network, send your traffic towards me. So what will happen when network B receives this BGP announcement? Actually, it doesn't have any idea if this information is correct or trusted. Maybe network A is really not the holder of that prefix. Maybe it is not authorized to originate that block. Network B, to be honest, doesn't have any idea, but it will trust anyway, and will put this information into the routing table and will start using it. The story is exactly the same for network B as well. So network B will announce its IP address block, network A will get it. It doesn't have any idea if this information is correct or not, but will put it into its routing table and start using it for forwarding. So network A, each time when it would like to access this network 2020 actually, it will always send its traffic towards network B. So this is how it works. So what I can say, BGP is just based on trust. Why is it like this? Because BGP is really very old protocol, which was designed many years ago, actually in 1994, and security was not a major concern on those days. On those days, the goal was just to make it work. So just provide connectivity between different networks. That's all, and nobody cared about the security part.
Sorry, could you stop for a bit? I see that people are writing something that they cannot hear the translation.
Okay.
Sorry, I just told colleague that yes, there should be some sort of control, like mute the original audio or whatever, which may make things better, but seems that quite a lot of participants do have problems with just hearing me, but I cannot sort it out for them. I just reminded them, please check this and that. Now we can continue.
May I go?
Yes, Sigdam, you're welcome.
Okay, I'm just going on then. So BGP, as I said, just based on trust, it's old protocol. It was not designed with security in mind at the end of the day. And so as a result, what may happen? Any AS can announce any prefix. Normally, BGP is based on trust, so we believe that everybody is trusted. We assume that, let's say, and we just assume that all the networks will only announce these prefixes, but all you know that even if it is the theory, in practice, it doesn't work like that. Anybody can originate any prefix. You can originate prefix of YouTube and hijack it. It's possible and very easy. And anyone can prepend any ASN to the BGP path and change the BGP path because there is no validation. It's just based on trust. You trust your peer, and when you get the BGP announcement, you just add it into your routing table.
Please speak a bit louder, a bit louder if possible.
Sorry?
Speak a bit louder, maybe again closer to the microphone or something, because now it became a bit
okay.
lower volume.
Okay, it should be good actually. Maybe your headphone, I don't know. Okay, sorry for the interruption. I'm just going ahead again. And any other issue with BGP is that there is no encryption or authentication. So, which means that BGP packets are sent unencrypted, so attacker can intercept them, or there is no peer authentication by default, so which means that anybody, the attacker, can impersonate actually the actual BGP speaker. It's possible as well. So what I can say as a result, BGP is vulnerable to attacks. And every year, thousands of BGP incidents are happening. And some of them are attacks, as I mentioned here, because BGP has many security vulnerabilities. But what I can say, to be honest, most of them are just accidents. They are unintentional. They are just mistakes, human errors. For example, typing errors. Let's think that you are announcing a prefix, your prefix, but while you're announcing it, by mistake, you just type the wrong number. For example, instead of 2, you just press 3 and announce somebody else's prefix. It is normal. It's really very easy. And as a result, you can hijack BGP prefix of another network, announce their prefix. And other thing, the configuration errors. For example, you may have faulty BGP filter configuration. And it's really very critical, especially when you are multi-homed, because if you don't have the proper filters in place, you can leak the routes to the other provider's connection. You can accept the routes that you shouldn't, or you can announce the routes that you shouldn't. And you could use as transit very easily. Or something else, ASPED prepending mistakes. ASPED prepending is some kind of traffic engineering technique, let's say. So what you do actually, while you're announcing the BGP route, you put your AS number, you add your AS number several times. So you make the ASPED longer, but less desired. But let's think that while you are configuring ASPED prepending, for example, what you would like to do, prepend your AS number for 3 or 4 times. But instead of writing it or repeating it for 4 times, you just write your AS and put number 3 or 4. So what will happen? It will not do ASPED prepending. You will just change the origin of the route. Or whatever, you are prepending your AS and writing it for several times, but you just made a typo error again. For example, your AS number is 12345, and you just, by mistake, wrote it as 13245. And what happened? there is another AS in the middle of your AS path. So it is another kind of issue, problem actually. So it is really very easy, okay, to cause some kind of BGP incidents just because of the typo errors or configuration errors, and you may cause BGP hijacks or unintentional route leaks. But at the end of the day, if it is intentional, or let's say malicious activities, or it is just something unintentional, or let's say it is just human error, it doesn't change the result. What will happen at the end of the day? Internet routing infrastructure is affected. So the question is that, okay, now we know that BGP is vulnerable, and it may be vulnerable to issues, attacks, or let's say just accidents. But how can we make internet routing infrastructure more secure and robust? So the problem is that it is based on trust. When you get anything, you accept it because you trust your peer. Then what we need to do, when we get the BGP routes, first we need to verify that if this information is correct and trusted or not. How can we do that? We can check, we can validate the origin if the AS who is originating the prefix is really authorized to originate it, if it is really the legitimate holder of that prefix or not. And the other thing, of course, also we should check and verify the whole AS path as well. And of course, filtering is really very critical because you should stop this wrong information from propagating the whole internet. And of course, how can we do that? Because it is the idea, okay, if we do that, it may help, but how can we do it? First thing, always check your prefixes before announcing. Because you see that there are thousands of issues, BGP incidents are happening every year, but most of them are really, thousands of them are just because of the mistakes, human errors. So be careful with the typos, be careful with the configurations. So check prefixes always before you announce them. And then what do? Register your routing information in the IRRs, or let's say routing registry databases. It is the database, distributed database, where you register your routing information. For example, when you announce any prefix of yours, put a record into the routing database, register it, so that everybody knows that this prefix is yours, and only you are authorized to originate it. If somebody else originates it, then they can understand this is some kind of fake or untrusted information. And then, of course, filtering is really very critical. Filter your routes. Filter your routes based on verifiable information. How can you do that? Of course, what is the verifiable information? The route information registered in the IRRs. And many upstream providers, many service providers are using IRR-based filtering. So they are creating BGP filters based on the registered routing information in the IRR databases. For example, RIPE NCC is maintaining RIPE database. It is not only numbering database, it is also routing registry database. It is an IRR database where you register your routing information. And there are several routing databases like this. As far as I remember, 30, something like that. And some of them are run by regional registries, some of them run by different organizations. And there are many, it is distributed databases. So whenever you announce your prefix, you register it in a database. Why? Because by using this information, the other networks can do verifiable information. They create their BGP filters based on this registered data. So it's really very effective, but what I can say, okay, IRRs are good. Yeah, it's important because you are registering your routing information or the others, and what you are doing, you are creating BGP filters based on this registered data. But unfortunately, there are some issues, to be honest, with the IRR system. What is the problem? As I said before, it is distributed database. There are 30 IRRs. Some of them managed by regional registries, some of them run by big service providers, commercial. So it's a distributed database. Mostly they are mirroring each other, but it's possible that some old information may remain in one of the IRR system, and two IRRs have some kind of conflicting information. And in this case, which one will you trust? So this is one issue. And the other one is that there is no central authority. Okay, for example, I'm announcing a prefix and I go to the database, IRR database, put a record, register my routing information, but maybe I register it wrongly, or maybe I registered somebody else's prefix. So there is no one controlling that. And the other thing is that there is no verification of ownership. In the RIPE database, by the way, we do that, but it is not the case for all of them. So which means that even if it is not your prefix, you can go some IRR systems and register that route as if you are the one who is authorized to originate it. You create route or route 6 objects and register it. Nobody checks if you are authorized or not updated properly. For example, let's think that you are announcing a prefix, but you forget registering it in the IRR database. Or, for example, some people are updating, or let's say stop announcing the prefixes, but forget about updating this information in the database. So it is not really, it might be outdated, or let's say the information may not be so correct. So as a result, what will happen, what we can say, unfortunately, IRRs are not so accurate. And data in IRRs is incomplete. So if everybody does not register their announcement there, or does not properly update them, how can we say that this information is complete or this information is well maintained? We cannot. So what we can say that, okay, IRR is really good only if IRR entries are correct. For example, for RIPE database, it's really very good IRR system because its correctness level is really very high. But it is not same for all IRR databases. So there are some concerns. What we can say, while you are using IRR system, actually most of the providers or most of the networks using some kind of tools such as BGP, Q3, level 3, filter gen, whatever, to connect to the IRR system, looks for the autonomous system in question and gathers the prefixes registered for it or associated with it and creates the BGP filter configuration automatically. But before you apply this, let's check it first because it may not be so correct. Do not copy and paste it directly, what we can say, because as I mentioned before, IRR filters are good, but only if IRR entries are correct. So that's the reason why internet community actually came up with RPKI solution. So let's talk about then what is RPKI, how it will help and solve all these problems, all these vulnerabilities in BGP. Actually, it's not addressing all vulnerabilities, it is just addressing the trust part, let's say, or the validation part. So don't think that we will not be talking actually all the security vulnerabilities of BGP and all the measurements. So we are just discussing about the validation part, the vulnerability, this vulnerability, specific vulnerability, and how RPKI is designed to help this. So what is RPKI? RPKI is, as you see here, it stands for Resource Public Key Infrastructure. So actually, we are using X.509 PKI certificates, public keys, private keys. We are signing something with a private key and validate this information with a public one. So it is the same thing. We are using PKI certificates, but with some extensions for IP addresses and AS numbers. So that's why it's called as resource certification. And it's a security framework which was designed to make routing infrastructure more secure and robust. So how does it help with routing security or the validation parts with this vulnerability? How RPKI helps? Let me explain it. So remember that what is the problem? What is the specific vulnerability with BGP? There is no validation. It's just based on trust. You trust your peer, accept everything what your peer announces to you. And we don't know actually who is originating the prefix, really authorized to originate it or not. We have no idea. And of course, there is an IRR system where people register their routing information, and you can use this, okay, while creating BGP filters. But there are some concerns, as I mentioned before. On the other hand, RPKI is another solution and a better way, let's say, most powerful tool to fight against this kind of vulnerabilities. Why? Because what it does actually, it verifies the association between resource holder and its resources. So it is a way to verify that, okay, there is a resource and this resource exactly really belongs to that network. We are verifying this information with RPKI. So what it does actually, it proves holdership. It proves that this network is the legitimate holder of that prefix and authorized to announce this IP address prefix. And it proves this information by using public key and certificate infrastructure. Now, today, we are using RPKI to validate origin of BGP announcement. So by using RPKI, whenever we get BGP announcement, now we know we can control who is originating the prefix, is really authorized to originate it or not. We can verify this information, but we cannot validate the whole BGP path right now. But of course, also, it is a stepping stone for path validation as well. So not now, but in the future, in the near future, we will be using RPKI data or RPKI infrastructure, let's say, to validate the whole BGP path as well. So let me explain how it works. It ties IP address ASNs to public keys. So we are actually, what we are doing with RPKI, we are registering our routing information. Whenever you announce a route, you go to the RPKI system and register your routing information. But different than the IRR system, now we have cryptography. We wrap it with the signatures. And also, RPKI is based on regional registries. And you know, there is a contractual relationship between the regional registry and resource holder. Then regional registry can verify who created what in the RPKI system. And with RPKI, what you are doing actually, you are saying that, okay, this is my IP prefix, but I authorize this specific ASN to originate my prefix. And as the holder of the resource, you just sign it with your signature. So let me explain how it works. It is using RIR hierarchy. So, you know, in the RIR hierarchy, we have regional registries, they distribute resources to LARs, LARs distribute resources to the end users. So we have something similar hierarchy in RPKI infrastructure. So at the top of this hierarchy, we have regional registries. They are called as trust anchors. And all these five regional registries have self-signed root certificate for all the resources. And root certificate, by using this root certificate, regional registries sign members certificates, the LAR certificates, the resources, let's say, which is called as LAR certificate, which is created upon request. So let's think that I am an LAR, I am a member, and I would like to implement RPKI in my network. Then what I do, I request it. And then RIPE NCC, by using the root certificate, by using its private key of the root certificate, creates an LAR certificate, signs it for you. And then what you do, by using your LAR certificate and your own private key, you can create authorized statements, and later on we will call them as ROAS. So RPKI is based on chain of trust, because remember that RPKI actually is used to verify the association between resource holder and its resources. So what we are trying to verify with RPKI, okay, this resource really belongs to that resource holder. So how can we provide trust in RPKI? It is this one actually. So there is a connection made starting from root certificate up to the authorized statement. So regional registries, 5 regional registries have self-signed root certificate for all resources, and regional registries use root certificate to sign LAR's resource, the LAR certificate. And as an LAR, by using your private key, using your own certificate, you sign your resources or create authorized statements and say that, okay, I authorize this ASN to originate my prefix, and you sign it with your signature. So there is a chain created actually. And let's talk a little bit detail so that you can see the full picture. So what I explained till now, why we need to implement, how RPKI helps with routing security, and I talked a little bit about the RPKI framework. But let's now move to more practical part, and let's see actually the whole picture. So when we talk about RPKI, actually it has 2 parts. The first part is signing, which means you are creating ROAs. You are creating authorized statements. Whenever you announce a prefix, you go to the RPKI system and create some records and authorizes an ASN to originate your prefix. You create ROAs. This is the signing part. And in this part of the session, I will explain it. And the other part is validation, which will be explained in the second part of the session by Alex. So validation means that now what you do, you are verifying the others. Okay, in the signing, you are creating authorized statement and say that, okay, this AS can originate my prefix. And you put this information in the RPKI system. In validation part, there are a lot of ROAs, a lot of authorized statements in the RPKI system created by all the networks, all other networks. And in the validation, what you do, you download all this information and use it to validate your BGP announcement. First, you check them. All these authorized statements are valid. The signatures, you check it by using the PKI structure. And then you use this RPKI data to validate your BGP announcement. And these 2 parts are completely separated from each other. You can do only signing, which means you are creating ROA, but you are not doing BGP origin validation. It's possible. Or you don't create ROA for your prefixes, but still you do only the validation part. So it is completely separate. It's completely up to you. But of course, what we recommend, if you would like to feel the full power of RPKI, do both of them. Create ROAs, authorized statements for your prefixes, for your BGP announcement, and also validate the routes you receive from your peers by using BGP origin validation. So let's talk about this signing part, creating ROAs. So what is a ROA? As I mentioned before, ROA is an authorized statement. So what you do, you create some record like this in the RPKI system. And what you do, you define the prefix, max length, origin ASN. And what you do actually, you authorize these as 1, 2, 3, 4, 5 to originate this prefix. And with this prefix length, so if somebody else, another AS, tries to originate it, it will be considered as invalid or untrusted information by the others who are validating their BGP announcement. And as an LAR, you can create ROAs, these authorized statements, only for your resources, only for your IP address block or your BGP announcement, let's say. And multiple ROAs can exist for the same prefix, which means that you can create 2 different ROAs for exactly for the same prefix, but with different ASN. So which means that you authorize this ASN and that ASN to originate your prefix. Let's think that for example, you are moving from one service provider to another, and for some period of time, you need both of the providers to announce your prefix. And you can create two rows actually for the same prefix with different ASN. So what will happen? For the other networks who are validating their BGP announcement, they will consider both of these announcements are valid and trusted information. And rows can overlap as well. So you can say that, okay, this is my AS, I will be announcing the bigger block, but you delegate, for example, 1/24 to your customer, and your customer will be announcing it. So you can create another row for specific, more specific /24 and authorize your customer AS to announce it. So rows can overlap as well. So what is in a row? As I mentioned before, row has three pieces of information in it. We have prefix. This is the prefix for which you are creating a row. Origin ASN. This is the AS number that you are authorizing, or you are giving an authorization to announce your prefix. You can just write here anything. You can write your AS number, so which means that only your AS will be announcing it. Or maybe you authorize someone else to originate your prefix, you can do that. Also, there is a special case, you can put 0 here, AS0. AS0 means that nobody can announce it. So, for example, for the IP address blocks that you are not announcing right now, as a precaution, you can create rows with ASN 0. So if somebody tries to announce these blocks that you are not announcing right now, the other networks who are validating their BGP announcement will consider this as untrusted information and will never accept it. And max length, it is the maximum prefix length that row is authorized to advertise. It is a bit complicated, right? So it's not so clear what is max length, but it's really, really very important topic. So let me explain it with an example, what is max length and how it works. Let's think that AS3330, by the way, it is a RIPE NCC AS, and we have this IP address allocation. And what we would like to do, we are creating a row like this. And the row says that, okay, I'm RIPE NCC, I'm AS3330, and I authorize this AS number to originate this prefix with max length /22. It means that I authorize this AS to originate this prefix starting from prefix length to /21 up to /22. So if, for example, according to this row, if RIPE NCC announces this /21, it will be considered as valid BGP announcement. If RIPE NCC announces, for example, more specific /22s, they will be considered as trusted information as well, because of this max length starting from /21 up to /22, everything will be considered as trusted information. But what if, for example, RIPE NCC announces more specific prefixes such as /23 or 24? All of them will be considered as invalid information, invalid BGP announcement, or let's say untrusted information, which will not be accepted by the networks who are validating their BGP announcement. So it is really, really important to understand max length. Why? Because you have to write something there when you are creating row, and it defines actually the scope of your row. So let me explain a little bit and give you a little bit information about max length. Okay, now we know that we need to write something there, but how should we configure max length? Let me give you some tips. I will try to explain it with two different cases. So in the case one, let's think that you create a single row authorizing your entire /22 allocation. This is your /22 allocation. And for the time being, you are only announcing this specific /23. And you created a row like this, which authorizes all block, because /24 means that, okay, the row Okay, for example, the raw will cover any prefix, any announcement, which is starting from /22 up to /24. So I have /22 allocation and I create a row with max length 24, which means that if I announce /22, /23, or /24s underneath my allocation, all of them will be considered as valid BGP announcement. So it is really very easy way to create rows. Why? Because, for example, I have /22 allocation, but by the time I'm only announcing this one. But if I create a row which covers all IP address space of mine, then it's really very easy, because if I announce another /23 or another /24 later on, I don't need to create additional row. So it's really very easy. It makes sense maybe, but unfortunately, it opens up your network to forced origin attack. Let me explain why. Let's think that there is an attacker. It spoofs your AS and it discovers that, okay, there is a /24 that you are not announcing. And what it does by using forced origin attack, it actually originates this /24. And what it does, it's a fake message, actually, fake routing information. It puts its own AS number as the origin and the prefix language /24. So when the other networks that are doing BGP origin validation, when they get this announcement, what they will do? Okay, origin ASN is correct, /24 is covered by this row. Okay, fine, it's valid, but actually it is attacker's announcement. It is something untrusted, but you already accepted it. Case 2. This time, again, you have /22 allocation and you are again announcing only the /23, but this time you are more clever. And what you do, you only create row only for your /23, specific /23 announcement for the block you are announcing. And again, there is an attacker. It is again creating a fake message with your origin AS. And when the other networks receive those BGP announcements, this time they check that, okay, origin AS is correct, fine. What about the max length? This is /24, but this row says that this AS is only authorized to originate this /23. If this /24 is originated by this AS, it is not trusted information. So it will be considered as bad information or invalid information and will be discarded by the routers who are validating their BGP routes. So the idea is that always create rows for the prefixes you are announcing. Of course, it is easier to create a single row which covers all space, and if you announce several prefixes later on, you don't need to create additional rows, but it is not safe. So whenever you announce something, just create row only for your announcement. That is a recommendation. So if you have any questions, you can always write in the chat window and Alex will be answering them. So I will go with the presentation. Okay, now we know row is an authorized statement, and with RPKI, you are creating authorized statements, which is similar to route and route 6 objects we actually use in IRR system. What do? You say that, okay, this is my prefix, I authorize this ASN to announce this, but different than the IRR system, we have cryptography, we have keys, we have signatures. And also, since there is a contractual relationship between regional registry and the holder, now regional registry has the control and it verifies actually who is creating an object in the RPKI system. So it's really very trusted. So let's see how we can create rows. But first, I would like to summarize this certificate structure again. So you see, we are using RR hierarchy. At the top of the hierarchy, we have regional registries. They are all called as trust anchors. So which means that trust is assumed, not their right. So we believe that they are trusted. And all these regional registries have self-signed root certificate for all resources. And by using this root certificate, regional registries signs these member certificates or LAR certificate, let's say, and the LARs can create authorized statements, rows for their prefixes. How to create a row? Okay, I would like to implement RPKI and I would like to do the signing part. I would like to create a row, but how can I do that? First, log into the LAR portal, then go to the RPKI dashboard, and first, you need to choose which RPKI implementation to use. So when you connect to RPKI dashboard for the first time, you will exactly see this. And we will ask you, okay, would you like to use hosted or delegate? Of course, we are giving some more information here. And in the following slides, I will show you the bigger visual so you can see what is written there. But let me explain briefly what is the difference between hosted and delegated RPK implementation models. If it is hosted, as you see here, it's as the name implies, the regional registry, in our case, RIPE NCC, will be hosting a certificate authority for you. And we are, as regional registry, we are doing everything, all the cryptography, we are managing it. So what you do as an LAR, you go to the RIPE NCC's member portal, the RPKI dashboard I showed you on the previous slide, and you just create your rows, that's all. And then what we do all the signing part. We create your keys, manage your keys, key rollovers, and we publish your rows, your authorized statements to the RPKI repository of RIPE NCC. So we manage everything for you. And from the perspective of you, if you are using hosted RPKI, what you need to do, just go to the RPKI dashboard, create rows. That's what you need to do. But if you would like to say that, okay, I would like to manage everything by myself because I would like to have really control on all of this, the keys, how the signatures, how the cryptography is done, whatever, I would like to manage it, everything. Then you can go with delegated solution. So which means that this time you need to run your own certificate authority. You need to create rows on your own RPKI dashboard. You need to create your own keys, manage your own key rollovers. You need to manage all the signing, all the publishing part, and your rows will be kept in your own repository. So everything is handled by you. But of course, we have chain of trust, right? So we need to make a connection between your certificate authority and the root CA. And you need to create your LAR certificate here, but it needs to be signed by this root certificate so that the connection is made like this. So, and also let me tell you one more thing here before moving ahead. The nature of RPKI is delegated, where you manage everything by yourself. But for the last 10 years, there was not really very well maintained or supported, let's say, certificate authority or CA software available. It was not available for the last 10 years. There was only Dragon Research Labs, but it's not really well maintained. And as a result, actually, yeah, there was not many implementation of delegated RPK. There was only 2 or 3 LARs I remember that were using delegated RPKI. But at the end of 2019, NLNet Labs introduced CRIL, which is CA software, which means that you can use to set up your own certificate authority and you can go with delegated RPKI. But of course, it requires more control and more experience. So you can ask that, okay, in which case I should use hosted or delegated? That is the question. So that is the answer actually. Here we show you, okay, here you see that you have 2 options, hosted and delegated. Select hosted. If you like, RIPE NCC do everything on behalf of you. Host your certificate authority, host your keys, host your rows in its RPKI system, and publish everything to RIPE NCC repository, and you just create rows, that's all. But select delegated to run your own certificate authority and host your own keys. So you do everything by yourself. And it says that select hosted, there's the recommend option if you are not an RPKI expert, and select delegated. then of course, which means that you should be much more experienced. You need to install CA software. You need to manage everything, all the infrastructure. So you can say that, why should I use delegate? Because it's okay, it gives control, but a lot of work behind it. It has some advantages. For example, let's think that you have IP address locations from different regions. For example, you have some IP address space allocated to you by RIPE NCC, and in order to create ROS for these prefixes, you need to go to RIPE NCC RPKI Dashboard and create ROS there. But also you have some IP address allocation from RIM or Afrenic maybe. Then you need to go there, RPKI Dashboard, and create ROS there. So ROS there, over and there. So you have to create them in each regional registries on RPKI Dashboard. But if you would like to have your own unified dashboard, then you can go with delegated RPKI. Also, if you implement delegated RPKI, you can also offer hosted or delegated RPKI service to your customers as well. And this is the RPKI dashboard of RIPE NCC. So if you go with hosted RPKI, then which means that we will create a certificate authority, we will host it for you on our platform. And after that, when you access the RPKI dashboard, you will only see this. So what do you see? Since first you need to access here with your RIPE NCC account, the LAR account, and then you will see only your own BGP announcement. So what we do when you sign in to RPKI dashboard with your LAR account, we filter your BGP announcement from the real global routing database. We get this information from RIS routing information system and reflect it here. So you will only see your BGP announcement. You can choose them and create ROS for this announcement. And here you see there is revoke host CA. Of course, you can always start with hosted RPKI solution, but later on, if you would like to move delegated RPKI, anytime you can do that. Just you revoke hosted CA. So everything will be removed from our hosted platform, and you can create your own CA, you can run your own CA and use delegated solution. And if you would like to, if you have a question, for example, if I have PI resources or my end user, my customer has PI resources, I'm the sponsoring LAR, for example, is it possible to create ROS for PI resources? Yes, it's possible. So the end user may request it, or the sponsoring LAR can do that on behalf of the end user. What is required? There is a link actually in the documentation you will have. There is a PDF form we will share with you, the presentation. And there is a link. If you click there, there is a wizard. And if the end user or the sponsoring LAR fills that wizard, then they will have access to this website. This is actually the RPKI dashboard. And the thing actually, they will exactly see this and will see their PI resources and will start creating ROS easily. So before completing my part, I would like to show you actually how we can create ROS. Let me check if the link works. Yes, it's great. So it is not that one actually. Okay. Okay. So this is the RPKI dashboard. This is just test environment. And here you see that this is my RIPE NCC. I just sign in with my RIPE NCC account automatically. And here, of course, when you connect your LAR account, you will see your LAR's information and you will see your BGP on BGP announcement. So here what I see, okay, this information is coming from global routing table, and I see that, okay, AS 2021 is the, my AS as a training, let's say, and now I have 2 BGP announcements in the global routing table, and the current status is unknown. So nobody knows if this information is trusted or not, because there is no authorized statements created yet. There is no ROAS created yet. What do? I choose them and say, create ROAS for the selected BGP announcement. And it says that, hey, the state is unknown, but when you do that, they will be considered a valid BGP announcement. Maybe it doesn't make so much sense what valid means right now, but after the first part, Alex will explain it in detail how the validation works. But what I can say right now, when I create ROA, I will say that, okay, I authorize this AS to originate this prefix. And since there is already a prefix in the routing table, in the BGP table, and since those two records match, I have trusted information. So the BGP announcement will be considered as valid by the other networks requiring BGP origin validation. And if I'm using hosted RPKI solution, or you are using hosted RPKI solution, that is what you need to do. Just create ROAS and then just say publish changes. It says that, okay, you are creating these ROAS and those are the affected announcements. So when you do that, what will happen? They will become valid, or let's say trusted information. I do that. And what happened? The ROAS, the authorized statements I created, now published to RIPE NCC RPKI repository. So ready for the others to be downloaded and used for BGP origin validation. And also what I can do, I can go to here and I can create more specific ROAS. So for example, what I say that, just give me a sec first, because I need to create two specific ROAS that actually Alex will be using in the second part. So let me check it. I don't want to forget about creating the correct ones. Just a sec. Okay. So I will create a more specific row. It's really very easy. You just say new row and then you write the AS number. For example, I authorize AS 102 to originate this prefix 193.0.25.0/24. And then I give a specific, the max length, because I cannot leave this field empty. And then I just save it and publish it. Apply it. Okay, it's ready. Create another row. This time I create a row like this, so which says I authorize AS103 to originate this prefix 026.0/24. Yes, it's fine. And I just press this floppy disk, review, publish changes, apply it. Now all is done. Here you see that, okay, there are 4 rows created, and for these 2 rows, you see there is a BGP announcement. It says that, hey, you created this row, and also in the global BGP table, there is a BGP announcement, and they match. So that's why the status is valid. And for these ones, hey, you created these rows, but really there is no BGP announcement right now. But in the second part, while Alex is doing the validation lab, he will show you and he will announce those prefixes and will show you how route origin validation works, how the statements actually or routes will be considered as valid or invalid. So this is my part. And we are a little bit over time, but it's okay. So now we have 5 minutes break. So what time is it right now? So let's start at 15 with my time. It will be
16,
16, right? 16.
Да, 4:15. Да, ровно через 5 минут.
Okay.
Yeah,
And
precisely 5
Alex
minutes.
will go.
Коллеги, давайте начнем вторую часть. Здесь у меня куда-то курсор потерялся. Ну ладно. Надеюсь, что критично. Все, я могу убрать лишний с экрана. Так, как Сигдам рассказывала в первой части, у нас есть технология, которая состоит из двух частей. Первая часть нужна для того, чтобы вы защитили свои ресурсы, чтобы другие могли проверить, что ваши анонсы они валидны. Вторая часть – это проверка того, что вы получаете от других, насколько валидны те анонсы, которые приходят к вам. Первую часть мы уже закончили, сейчас мы поговорим про валидацию. Для этого, для того, чтобы эту валидацию произвести, эту вот процедуру, существует несколько правил, скажем так, да? Ну, во-первых, вообще процедура называется Route Origin Validation, да, или BGP Origin Validation. Вот, и
we are talking about origin validation or BGP origin validation. So you can see both terms when you read any additional literature on that subject. And in order to run that validation, what do you need? First of all, you need a server with special software, which is called Validator Software. It's better to have it locally because it will talk to your router or BGP work. So the delay will affect the latency, will affect the performance of the whole thing, not to mention the reliability. Of course, if you have it somewhere else and you have some channel problems, then definitely you'll run into problems in case of any communication problems. Second, you need ROA from your repositories, from your RIR repositories used to check, and those would be downloaded by the validator, and then the validator has to validate them because some of them may be revoked. Maybe the certificate has expired. So respectively, you need some validation of whatever you download. And after that, you should apply the ROA you downloaded to apply to those addresses you get from the network. You classify those announcements as finally the most important thing. You make a decision what to do about each and every announcement based on the information we received on the previous step. So what is the validator? What sort of software it is? As I already said, it downloads RPKI repositories from IRRs and creates the chain of trust. Say, we got to the top where we have a public key, the top layer, and we can go along the chain of trust and do a check and validate that all those entities are whatever they say they are. And respectively, this information is then used to interact with the router using a special protocol, which is RPKI, so that the router will be able to validate those announcements. There is one thing here which was relevant in the past. Now it's become a bit less relevant, but in order to get those ROAs from registries, you need to use so-called trust anchor replicator. That's a small file, a very small, very short one, and it has a link to the repository and basically the public certificate. Why it is important? Because among registries, there is Arvin is a registry which is in charge of North America. There are certain fine nuances about it. Previously, it was impossible to distribute that TEL file, so you had to get clear consent, explicit consent to get it. But now it has been a bit simpler, but still, this is a legal story. It's not about any technology, any technical thing. It's just legal stuff. It's about some legal issues. But to install that file, you'll be required to clearly confirm that you understand what you do, that you use that TEL file from every registry. We will see it a bit later, but that's why we mentioned TEL files and the TEL file exists, and you have to handle them in a special way because there is this nuance. Now, after the validator receives the TEL file and knows where the repository is located, then it uses rsync or RRDP. Previously, it would be rsync. Now, good practices are about using RRDP, but these are technical things. So the validator uses it to get that ROA from each and every registry. ROA. After that, those ROAs received by the validator are validated by the validator to see that the whole chain of trust is validated. How are ROAs validated? We have certain record which uses LIR certificate, and we validate that this is the correct link, correct reference, and LIR references the root certificate, and we check that this is a correct reference. And of course, the root certificate is self-signed. There are many root certificates, they are public, they have been published. So all those ROAs we have can be tracked through the chain of trust to those root certificates, and there is not a lot of those, and we know them in our software. Our software is aware of them. That's the same principle, absolutely the same principle as was it used TLS and HTTPS. There is the same chain of trust up to a root certificate, which is in the browser, which is supplied with the browser software. And here is the same story, the same idea. It works the same way. So if everything is fine, if we manage to validate all of it up to the root certificate, then our ROA is valid, we trust. If, on the other hand, at some stage, at some step, validation certificates do not match, validation does not pass, then ROA is invalid. And those invalid ROAs are just thrown away by the validator, are not sent to the router. So the router would not see invalid ROAs, no way. So if anything happens at that stage, this ROA just not exist. What are software options for validator? There are actually 4 of those at the moment. Some of you may also remember validator developed by us, RIPE NCC, but we dropped supporting it because those options, alternative options that appear, have been better. And it makes no sense to spend time and energy to support our product when there are 4 excellent alternatives. There is an alternative from a lab called Validator. It's very popular, it's well known. There is Fort, a lightweight, good validator, quite new one, again open source. There is a product from Cloudflare, and there is an integrated validator in OpenBSD. So if you're using OpenBSD, you have RPKI client, which is built in OpenBSD. On this slide, you have links to all those products. So you're welcome to see any of those. It makes sense to think about diversifying, not to rely on just one validator, but to have some variety of at least two validators. We'll cover it in a bit more detail later. Now, if you have any questions, you're welcome to ask them in the chat before we switch to the next part of our agenda. Seems to be no question at the moment. So let's see how to configure them.
Обновление — это достаточно долгая история, то есть минут 40. Он не мгновенно все это дело выкачивает, поэтому для живой демонстрации.
So there will be no live demo how it works because it takes some time, but we have configured. We have a lab where we will run some demo today. There is a validator there in the lab already configured, or validators. There are two validators already configured, and we will be able to use them to check how they work. Maybe if you have time, we'll run a couple of checks to see how it works. Why does it make sense to have two validators? I think it's rather clear, because if there are any server problems, if there are any software problems, like nobody knows what will happen. Something may happen, and then one of those validators at some point in time and some data set will behave in a strange way. That's why it makes sense to have a spare option, a reserve option, and a spare option spare validator from a different vendor. So two different validators with different. They should be run, and all files should be configured. They are available for free.
Явным образом подтвердить. Опять-таки, как это делается, чуть-чуть позже покажем.
But you have to check it. We will be using Routinator, and we will be using forms. They are already installed and pre-configured, but on this website, on this slide, we'll show some important things. If we run the Routinator, we'll get an error message. We'll see an error message as we see it here. You have to initialize it. That's the process where all files are set up and start using them. So you just launch, if you run Routinator, for it to install the TAL file, we'll get another warning. Namely, because of ARIN policies, you have to explicitly confirm that you are going to use ARIN stealth. So the right thing to do is a sort command with that option, accept ARIN RPA. So to use relying party agreement, which will enable you to use all TAL files and to receive respectively all ROAs from all those registries worldwide. So the first stage will be initialization and configuring those TALs. Then we can start the Routinator. It starts with this command here, server, indicating the port for it to use. I think everything is quite clear here. And then we run the standard PS command, and you see it as a letter. You can grab to see that the process is here, that it runs. Yeah, there is this command, VRPS, which shows what we have downloaded from those repositories. If you want to check anything particular, you can grab it like you see it in this picture. Before that, there were several lines that say rsync, and so these, all these come to SDR, and if you don't want to see it, you can filter to redirect it. Now about port validator, this is quite a similar story, but you see, please download and read IRIN Reline Party Agreement. Again, and here you will see you'll have to type yes for everything to work successfully. So here clearly asked you have to confirm it by typing yes in response to this request. After you answer yes, those files will be set, and you can use this standard way. Way to start for the service, and again, in a standard way, you can check how this service works. It's a bit difficult, a bit more difficult to validate the downloaded stuff. Here you have to run some more sophisticated commands. First, to check that for this thing you can use either standard SS, or if it's not Linux, or some Linux where for any reason you don't have that SS, you can use S-Trace, which is cross-platform with different keys. And here you can filter the output using Ford, and you will see this record about the service, and you will see that indeed it is listening on that port allocated to it. Why S-Trace or SS? Because those utilities enable you to see which particular user and which process ID uses is about the process, that it's Ford, not anything, not something else. That's how it looks in the part, you see how to monitor service. And second part, to see that you have prefix among downloaded stuff, you can see if you grab that rows.csv, which is under that path you see on the screen. This is to check that everything has been downloaded and you can use it. Again, if there are any questions, you're welcome to ask them now in the chat. As far as I understand,
к следующей части. Вот у нас есть валидатор, который умеет получать RAW, который умеет проверять все RAW.
There is a validator which can receive RAWs and check those arrays that they're valid. And to do something, we have to integrate it with our routing process. That's how it looks in general. There is a validator. It receives a set of arrays, checks them, validates them, and uses RPKI protocol to send this information to the router, which is then used. So the decision is made by the router. So the validator just filters those arrays and prepares a set of valid arrays for the router. And the router makes a decision. Either everything is okay and that announcement is accepted and it will be used, or everything is bad, it's not accepted, or it will be handled somehow in a different way, in some non-standard way. Let's see how it works using some examples. We have this ROA For this prefix 10.0.0.0/22, its max length 22, and it all lives in the validator. And validator communicates with the router, which receives an announcement from AS100, this announcement, 10.0.0/22. As we can see, this announcement matches the ROA that we have. The max length again matches, it's 22, under /22, it has come with AS100, which is describing that ROA as a valid system to announce this prefix. Okay, great. Then this announcement is marked as valid. Then a prefix comes, which starts with the same 10.0.0 about /24. For 10.0.0, we have this ROA, which covers this /24. This must, but maximum length for this announcement is 22. 22 is more than 20/24. So this announcement is more specific and it's not accepted. This is very important because, as you understand, it's more specific. If it's accepted, it would override that announcement that could be used maybe for some illegal actions or something. So respectively here, we have this invalid BGP announcement. So this announcement is not valid because it does not, the max length does not match. Okay, now we have another announcement 10.0.0/22. So max length is okay, but it has come with autonomous system 200, S200. And ROA says that this prefix with this maximum length can only be retrieved from S100. We will not accept this announcement because in this case the S number does not match. So the max length, the S are very important, are fundamental when checking that ROA against our announcement. So there are these two things which are fundamentally important for this ROA to apply successfully for this announcement. What happens then if our S100 announces some address from Microsoft network, for example, 2020 or /22, that's Microsoft network come from S100. We don't have ROA for that. So we don't have any match. Nothing matches. That's a different story. Previously, we would see some match of that address block address space. It was covered by, but there was max length which did not match. For this address space, we just don't have any information. So here, this announcement will get a different state, not found. That's a different story. Because here we don't have any ROA. There's no ROA from this prefix. So this is another scenario we may see. And also sometimes it happens that there is just some sort of neglect on the systems administrator part. Some administrator did not check something and just left for holidays for something. Say, administrator is not available. Unfortunately, nowadays, currently in this war time, a lot of reasons may work for that person who configured something to be unavailable. And that person made some mistake. That's the example we already saw. When there was an announcement 10.0.0/24, more specific one, yeah, that's the right announcement. Proper announcement, but the person who configured it did not create an ROA as described by Secret. So the first part was not done. And this announcement has to be rejected but for some reason we want to accept it, even though this is a wrong announcement. So we are in contact with some people in charge for that AS100, and they confirm that everything is accepted. For that, whitelisting procedure, validator whitelist. So even though this is a valid announcement, you can include it in the whitelist, and then after that, that validator will treat that announcement locally in an exclusive way. And that will be an exception locally. Your router will accept it and handle it properly. Not globally, but locally. So, of course, it always makes sense to have as few exemptions, exclusions as possible. You have to understand that if it goes any further, people on the global scale will not include it in the right place. So that's an exception, but sometimes it may make your life easier locally. Now we will briefly run that lab, see that lab, and we'll try and do it manually to see how it works. We have our local cert, we will not download everything. We have a local cert, which is configured for a small number of ROAs. We have our autonomous system, RAS, which announces those prefixes. Remember, have them in the system 193.0.26.0/24. There's the right proper prefix from AS102. In our case, it will be 109 ethical check. There will be also somebody else's prefix announced, which belongs to a different AS, which is not in our ROA. As I already said, we will be using two validators, Spot and Routinator. Those have already been configured and already running. So, respectively, we will be using RPKI RPR, and basically we will be simulating those two situations with the proper valid prefix, unknown prefix, and hijack prefix. So you already saw this picture. That's what Sigma prepared for me. She configured those prefixes. Now we will set a basic configuration for interacting with validator, because first of all, we need this router to know where the validator is. Then we'll check that the session has been established, that this router sees this validator, and then we'll configure BGP to get those announcements we want to get, and we'll see how the statuses will change, how the statuses will look for those three announcements. Again, I will describe them in exactly the same way in terms of configuration. They will look the same way, all the services, and the only difference between them will be at this level. No questions, okay, great.
Сейчас я переключусь на оборудование. Вот оно. Надо переподключиться. Вот здесь вот у нас живет.
Reconnect. Here we have our validators. Here we can run those commands to discuss, to check them. And if you have slightly different AS numbers, 108 and 109, and we'll use them to run those things we discussed. So first of all, in this S108, we need to 108.
Алексей, не видно CLI.
Прошу прощения.
We can see.
Все еще смотрим презентацию.
We are still looking
We
at your
cannot see
presentation.
your CLI. We only see the presentation.
Got it. Так, одну секундочку, сейчас я расшарю. Ага.
Just a moment, I'll share my screen. No.
Коллеги.
Colleagues?
Да, видно.
Yeah, now we can see it. Great.
Вы видите,
And also you can make the screen larger, so it will be easier.
да. Я. Вот, вы видите, что я пока успел только набрать,
You
собственно,
see that I just managed to start configuration mode for this 108. First of all, we tell our router where do we have our validator, our routinator and fork. They are at this IP address, as we remember, and port for routinator and refresh 5 minutes. And the second validator port is on this port. So we can configure that. Now we can check and make sure that there is connection to those, and to do that there are two
вам, наверное,
commands.
Вот, сервис и table, да, ну, то есть в сервис очевидным образом.
Service, of course, we see information about servers, we see information about connection to both validators and to filter a lot of information. So to filter, we can just filter it using state, where the state is stopped. That means that the connection is successful. There are two validators, we have two stop states. Yeah, okay, validators are working. If you see the table, we'll see the prefixes. We'll see those ROAs, which we received to analyze our prefixes. And again, we can filter using any given prefix. And we see that for each and every prefix, please look here, we have two records for each one. There is a record for fork as a validator and a record for routinator as a validator. You see the fork port and routinator port. So the very first stage has been successful. Connection to the validator has been established. Now let's try and run those announcements we would like to validate. So here, AS1, we see AS109. It all happens in IPv4. So, first of all, to describe Microsoft network in a tricky way, I'd like to remind you, you all know it, but just in case, historically, Cisco has this addressing, so we have to indicate the network mask. Then we indicate, we type a legitimate the address that we are going to announce in a legitimate way, and an address we are going to hijack from somebody else's AS. And to have it all sent, we need some routes, so we will create those. We will create them artificially. Creating this route 193 and the third route. So that's basically we have set it up. Now here we can see how those announcements look in terms of from the router's perspective, router which has received it from 109 S109. So we are checking, validating them. The first announcement, which matches what this IS is authorized to announce. Just a moment. Why are they all valid? Sigdem, have we created everything properly in our way? Because you see that both are indicated as invalid. You see this Microsoft prefix 2020/20/24. It's not found as it should be. It's not found. While 193 or 25 are both invalid for some reason. Let's try and check what do validators say.
RS. Ноль. Понятно, да. Я прошу прощения, да, я зашел
I'm sorry, I used the wrong account to log in. I logged in with the wrong account. Yeah, it was configured from 101, 102, and I logged in from 108, 109. Let me log in again with proper numbers, and we'll do the same there.
Сейчас быстро все перенаберем. Один, соответственно, у нас в этой истории. BGP. Набираем. RPKI. Server TCP. У нас адрес 164.1. Теперь оригинатор.
this is coordinator.
Да, здесь все есть. Это, соответственно, 102. Отлично. Соответственно, здесь у нас 20.
So here we have 20, 20, 20.
Ноль. И, соответственно,
26 and
5, 0 и 26, 0. Прекрасно. Так, все воспроизвели.
so we have we created it. BGP 193.0.25.0/24. So basically, there is an update. That announcement 193.0.25.0 is about 102. Yes, it's valid, and it should be 26 is our hijack prefix, which should be announced from another AS, and it has a status of invalid, and the Microsoft network, which was not, which has no array or no row, it says not found. So the router managed to properly check based on the existing rows. It has classified those announcements and properly assigned statuses to them. So this is, an important part of work has been done. But that's not it as yet, because, okay, we have a status, but now, of course, we have to do something about that status. Let me switch to the presentation. So we see our results in color, like everything works as it should. Now we need to use the classification for some practical result. We don't just know that we have some invalid announcements. Now we have to do something about them, because it's quite possible that this is some malicious activity. Some people have been trying to do something against us or against others' networks, so we have to stop it somehow. How it's done? First of all, I'd like to remind you that we have three stages. We have to filter invalid announcements. Currently, there are quite a lot of networks worldwide which are not signed, so we cannot filter not found in any way, because we will lose interoperability of networks. We should only drop invalid, but it may be that if you drop them immediately, something will break immediately and in several places. So a good practices are about gradual drop. Say, for example, first you can lower local preference. At least to start with, you'll see what's going on. Then you can tag, you can color those invalid announcements, which are invalid, with BGP community, and then you'll see where it is to look at your network and understand, like, if such announcements disappear, those color tag announcements disappear, how it will affect your network. And clearly, if you tag them with color, you can do something. If you tag it, you can do something with that community. You can use various scenarios how to handle the situation. And finally, what should we finally achieve? You should learn how to drop invalids, preferably as many of those as possible, because they are a threat for the routing system. So again, we'll see live demo now. We'll use Cisco using the classical route map method. We'll create the route map, which is there. We'll say that we let valids get through. We lower prefs, local prefs, preferences for unknown announcement, and by default, then there will be a prohibition for those unknown which are invalid will be blocked. And then we apply this route map to a session and another router will see the session and what happens as a result. So again, I switch. So I'll switch again to our demo lab environment. Just a moment. Share screen. Can you see it now? Colleagues, can you see it? Not yet. Ah, now we see it. Great. Okay. So we need our router will create a route map here. Let's name it RPKI accept. We want to match not IP, but sorry, just match RPKI. And what else did you want? Set preference a bit higher. Then the next record.
Раз у меня сегодня руки кривые.
Today I don't type that well. So we match that status. By the way, here you can always see that help, and now we set local preference a bit lower, just to be sure. So what have you done? Again, I'd like to remind you what you've done. We have made this route map, and now it would be nice to apply it to the session with our neighbor, so to say.
Так, а зачем это самое? Зачем мне адрес family? Прошу прощения.
Sorry.
А, нет, ну тогда мне нужен адрес family все-таки.
I need it.
Там 168, 1, 254. Да? На него мы хотим повесить
And we want to apply to this roadmap, which is called RPKI accept.
Вот мы это дело повесили.
Now we have applied it.
Надо перегрузить.
Now we have to refresh to relaunch the session.
С вот этим самым товарищем.
With this thing.
И, соответственно, теперь мы можем
So now
посмотреть, что у нас поменялось.
we can look and see what has changed
Выглядит у нас анонс.
in how in the way our announcements look. First of all, we'll check the announcement which was valid. Now it's still valid and everything is okay with it. As you can see, after we applied the route map, which filters out invalid, nothing has changed here. Now we'll check the announcement we tried to hide. Now see that now it's not in the table. Since we applied, it's not unstable. Since we applied route map and the announcement received has become invalid, was filtered by the route map. So it's not it's not part of BGP decision making anymore. It has been filtered before it could be used in any way. And the last network we borrowed from Microsoft, so to say, has a status of not found. We allowed not found, but it has local pref 90. We made it already. So it just has a bit lower local pref. That's how this mechanism works. We see that we establish the session first, then we see how to get the information about the session from the validator and how to classify our announcements. And the third part is how to use this classification of announcements to filter out those announcements which should not be accepted. So now we switch back to the presentation. There's just a little bit remaining. Please be patient.
Вот, собственно говоря,
so that's basically you see in this slide what we saw. 25 is valid. We accepted it. It has higher local pref because in the roadmap we said that such announcements would have this local pref. This one has been hijacked and it has not been accepted in any way. And the one which was unknown to us is there in the table, but with lower local pref. Yes, I said 19 here. It has 80 in this example, but it's not a matter of principle, of course. I don't see any questions in the chat. Now let's look at statistics quickly, and then we'll switch to Q&A and we'll finish our today's discussion. That's the global situation with RPKI. A bit more than 1/3 have subscribed, 37% have subscribed, including about 1.6% which are invalid. Most probably in that 1.6, quite a number of those are precisely those human errors mentioned by colleague when people just recite some numbers. But there is this percentage, 35.4% are valid announcements. That's how the graph chart looks. This is the progress. We see that 9080, this is a straight line, which is quite stable. It is not curved, and most probably will not, but it's still far from 100%. And when there is saturation, it's not that it's quite far yet. Now, RPKI is not checked, it's not validated everywhere. Unfortunately, we cannot show the second part. There are networks subscribed, but we don't have statistics on networks being actually validated. But again, about validation, I would say that it changes the process the same way. Now, out of say 12 Tier 1 worldwide, 3 of them have been validating RPKIs, and several more have been are going to implement it really. So here we see some very interesting statistics. 25 autonomous systems with the most prefixes observed, and we see Ukrainian Tier 1 here. I was interested how it happened. Why has Tier 1 been within top 25 ISs worldwide with a high number of prefixes? But it turned out that Tier 1 just deaggregated their announcements. It's their networks into /24 has signed each of their /24. As we know, there is not a lot of announcements from anything less than /24 on the internet. At some stage, those announcements are cut. So Tier 1 has taken their more specific prefixes and put all of them there. So all of them have been properly signed in RPKI, and it made Tier 1 reach such a high position. I think that's my personal opinion. I don't know whether we have any official position by RIPE NCC, but I personally believe that this is an extreme behavior when you make specific announcements for critical networks, for important networks is the right thing, that's a good story, but to make specific announcements and aggregate all of your announcements is probably wrong. But on the other hand, at least they have signed whatever they announce. This is good practice. Whatever you announce should be signed. Similar numbers about IPv6. Previously, we were talking about IPv4. No, global statistics for IPv6 are a bit similar, but there are more invalids, twice more invalids. So in IPv6 announcements, probably people don't care that much about those as much as about IPv4. And that's how progress looks like. You see again, it's linear since 2019. So no fundamental difference between versions of the protocol. Now, how it looks locally here in Ukraine, we've seen some growth since the beginning of 2021. You see a sharp increase in signing. You see this chart with absolute numbers of prefixes have been signed. And on the right side, you see the share of address space, not prefixes, but address space being signed. And we see that the situation here is not terrible, but it could be improved. There are less than 50% signed in Ukraine, and there have been some cases in the media in March about mass-scale Bgp attacks from Russian Federation, and it's because it's quite easy to do it. The share of signed address space is less than 50%, which is very sad. And for IPv6, we understand that unlike the global situation in Ukraine, you know, globally, 35% of users have IPv6. In Ukraine, unfortunately, it's less than 1%. And of course, wartime is not the right time to implement new protocols. So the number for IPv6 are even worse. But because this protocol has almost no use in Ukraine, it's not that important. That's basically it. Here I stop my part, and we are ready with Sigden to answer your questions. Sigden, there is a question: have there been any examples of it being used by the enemy? So again, if you have any ideas, what else you need, any questions about this training, any suggestions that could be done, you're welcome to address us, and we'll do it.
I was just answering actually in the chat. You asked that, are there any examples of enemy used as a Google translation? Actually, I hope it's correct. So there are lots of BGP issues, or there are lots of vulnerabilities of BGP. And in this webinar, we only address one of the specific vulnerability, no validation in BGP, that's all. But of course, there are a lot of vulnerabilities of BGP, and the attackers can attack your network in different ways by using BGP protocol. So with RPKI, we are only addressing to mitigate BGP hijacks, prefix hijacks, and also, let's say, misorigination. So you can hijack somebody else's prefix with originating wrong prefix because of typo errors, whatever. But if, for example, there is man-in-the-middle attack, which means that one of the attacker, let's say, spoofs your AS and your packet and puts its own AS number into the AS path list and just show itself as one of your neighbor and sends a BGP announcement and generate man-in-the-middle attack. It is not possible to detect it via RPKI. Or maybe somebody can change the origin AS of the BGP packet and can put its own AS number as the origin. So it shows that, okay, you are the one who is originating prefix hijack and hijacking somebody else's network, but actually you are the victim as well, because you are not the one who originated that route. Attacker announced a fake route and originated BGP hijack by using your AS number as the origin. It's possible as well. So there are lots of attack types. And unfortunately, this webinar is not addressing it, but I have good news for you. Now we are working on BGP, new BGP security face-to-face course, which actually discusses BGP security with all the aspects, all the vulnerabilities. So what kind of vulnerabilities in BGP and what are the measures to prevent those? How attackers can attack your BGP and what you should do to protect your network against these BGP issues or BGP accidents or incidents, let's say. For example, you need to protect your BGP router. You need to protect your BGP sessions. You need to limit the number of your prefixes you accept from your peers. You need to register your routing information in IRR and do IRR filtering with the trusted IRR, sure. And you should implement RPKI. You should implement really very good filtering. So there are a lot of measures to prevent all those BGP issues and which are addressing all vulnerabilities of BGP. And as I said before, this webinar focuses on only one of the vulnerability of BGP, which is there is no validation in BGP, that's all. But also there is no encryption, there is no authentication. We have never talked about them during this and how we can mitigate this kind of issues. We have never covered it during this webinar, sure. But as I said before, now we are working on new BGP security course, which will be ready actually at the end of this year, most probably. Then you will see all of them discussed in detail and with every aspect. So what is BGP security, how the attackers can attack it, because it is not only, announcements, it's also based on TCP. So attacker can actually attack TCP session and again destroy your BGP session as well. So different ways, and we will be addressing them in that face-to-face, and we would like to meet you again for face-to-face. But of course, we will put this content to the online tools, or let's say we will create webinars for this topic as well in the following time, in the following months, let's say.
Сигнал, спасибо. Давайте я быстренько...
I will quickly cover those questions. How safety, how security is to trust other validators? Well, it's an open issue, but Cloudflare, I think you can trust. On the other hand, public services, again, you should understand that public services can be maybe unavailable at some point, so you may run into problems with connectivity in wartime situations that we have at the moment. It's better than nothing, but you will have to carefully monitor the router connected to a remote service, because things may happen. On the other hand, if the validator is unavailable, then of course all those announcements will be marked as not found. That's not that terrible. But not found, if you're careful, if you monitor it, then that's a reasonable thing to install your validator. Server parameters. This is an operational issue. Marina, if you configure it, you're welcome to contact us, but server parameters basically are port used by it, and that's basically if you don't have any BGP client, we need a validator. If you're sure that your uplinks and those announcements are validated there, then you don't need it, then you're secure, you're protected. But if you're not sure, or if you don't know, then it makes sense to do it, because there may be an invalid announcement from the world, and instead of something, rather than go to the parliament side, you will visit something resource, which is not that good. Two validators do not conflict, because there are chains of trust for those ROAs, and there is the same type of verification. So they don't get any different information. They do the same job. They post the same job. If there is lack of synchronization, if they're not synced, it may happen that the network was used by somebody and then was transferred to a different entity, a different player. Then there may be a short period of time when there is lack of sync. That information is not in sync, but if at least one validation is valid, then it's accepted. If from one validator the router says valid and the other one says invalid, then this announcement will be accepted, again because of the chain of trust. When there is a mess, when there is some mess, there is a chain of trust, and it goes up to a centralized authority. And there may be just temporary inconsistency like that, when one of those validators has already updated it and the other one has not updated it as yet. On average, both validators should see the same picture. Yeah, that question was answered by Signal. If you want to use BGP transit, client prefixes, yeah, that's if those are your clients, if you're their LIR providing them with address space, if announcing your autonomous system, yeah, you add them, you add their prefixes if those are other players who have their own AS, if they are LIR and so on, then let them sort out their prefixes. If RPK services are unavailable, yeah, Signal already answered that question. You get the status of not found. If no one RPKI server is available, then you are not found. Okay. This is not a question, but a wish. Public validators, yes. There's a public validator service by Cloudflare. They said that's better than nothing. If you don't have sufficient resources to set up your own validator, you can use a public one from Cloudflare. Any examples of using by the enemy? Yes, there has been an example. I cannot tell you more details, but there has been such example. A recording will be available. I will send it to registered participants, and it will also be available from us. I will also send a link to that recording to registered participants. Trailan share. It may be that, yeah. It may be that Trailan, by the way, a good comment on country. I'll have to check. Where could you learn more? You know what? What I know is unfortunately not subject to disclosure, and generally, unfortunately, information about BGP attacks is rarely made public. It's a pity for me because as a result, people underestimate the severity of this problem, the importance of this problem. I have several links to foreign researchers who have seen some anomalies, and they describe them in general. If you're interested, send me your email address and I'll send you those links. Or you can search on your own, but if you need, ask me and I'll send them to you by email. There are some publications, but unfortunately, there's not a lot of details there. Why not embedding it in the operating systems? Well, I don't know, or why they didn't do it from the very beginning, because by that time, vendors said that we need too much resources and we have limited resources that would increase the cost of that box. Currently, the resources that box would need anyway, but RPKI was created quite long ago, and currently this reason doesn't work anymore. Why it's not done now? Actually, unfortunately, I cannot answer. Well, if you a lot of the time there are manifests, if you share, we'll try and contact them. Use of service resources, server resources when traffic is in excess of 40 gigabits. I don't know, cannot say anything. Basically, look, how does the validator work? It prepares lists of rows and downloads them to the router's cache in chunks, not separately, not individually, not one by one. So basically, the validator, there is not much extra load because of your traffic. Where there is a number of announcements does not affect it a lot because they're chunks. It sends arrays in chunks, and from time to time, when the cache expires, it's updated, and that's it. So we don't need a lot of server resources to do that. I suspect that 40 gigabit is still, you know, you have 2, 3, or 7. Will it be 1 gigabit or 40 gigabit? The number of messages, BGP messages, will not increase that much. So I suspect that there will be no major problems. there. It should not affect that much. About manifests, as I started saying something, I'll continue. We have a person, the department, maybe many of you know her because she participated in a number of our events and presented there. And she's in charge of RPKI at the moment within our organization. She's the manager of that program, and I believe that it would be useful for her to have that information about that manifest because she's in touch with many people who have been implementing RPKI, and maybe it will be correct that you can contact her via me if you don't have her direct contact. Could we add information to the dashboard?
РО, если вы имеете в виду и
Do you mean IRR? Do you mean that in our routing? Which I see now. Yes. Basically, it follows from what Signal said, that RPKI is an additional independent mechanism. But yes, maybe we should think about how to formulate. Indeed, root objects in the IRR database are not have nothing to do with ROA records. They are completely independent. There are no mechanisms to link them somehow, except for one. We have our RIPE project. By the way, there you can see the current status, how you see, how you look at the NAS in RPKI terms. And by the way, that's where I looked for Trail on the right stuff. And basically, there is a lot of information collected there. There is a separate tool. You can type a prefix and you'll see RPKI information and IRR information and how much synchronized there. So it's at the analytical RIPE sub level. On the operational level, they're completely independent. Yes, I agree. I also don't like new interface that much. I will switch to the old interface of RIPE state in 100% cases. Well, don't know. Maybe that's just tastes differ. Maybe those guys will finally understand that previously it was more convenient. We'll see. But there's a team working on it. That's their job. Well, I think that here we are done with questions. I'd like to repeat that we have you have our email addresses. They were on those slides, and they will be in that recording. And my email will be, you'll see the sender of that email. You will get when we send a link to the recording. Contact me anytime. I'm a RIPE NCC representative in Ukraine, so you're welcome to approach me with any questions you have, and we'll try and resolve those. Here, probably, I'd like to thank you. Maybe that's it. I have nothing to say. Maybe we'll add a couple of words, and we'll finish our webinar.
Okay, let me say something before leaving. Thank you everyone for attending and listening to us. I hope it was useful, and I hope I could answer your questions properly. I'm not sure if my Ukrainian translation was good. It's just a Google Translate. I tried my best, and thank you for answering questions in English. Sometimes it was easier for me. But if you have any questions later on, please send an email and I will try to answer. And maybe, Alex, you can share your email address again with your screen at the last slide. Actually, it was there. Also,
yes, let me do that
in PDF format with you as well. So
yeah, here we go.
Please feel free to write down here and just send them, and I will try to respond to you as soon as possible.
Yeah, sure.
Thank you very much.